All right, welcome back, guys. In this video here, we're gonna start discuss furthermore into the rules of probability. We're gonna try and combine both lesson 4.2, 4.3 in the next couple of videos. Um, so for addition rule, we have these notations, and we're going to try and get familiar with the notation first, and then we move on to the multiplication rule of probability. The first notation we have is P of A or B. This denotes the probability in an experiment or a single trial that either A occurs or B occurs or both event A or B occur. Then we have P of A and B. This denotes the probability in a single experiment that both event A and B occur simultaneously, meaning they share outcomes, common outcomes. Okay, so let's look at this through an example. Example 1: if one number is selected randomly from the set of 10 numbers, let A be the event that the selected number is even. Let B be the event that the selected number is less than 7. Sorry. So what we can do here is we can try to figure out what the outcomes for each set would be. For the event A, if the selected number is even, we can choose from 2, 4, 6, 8, or 10. And if the number selected is less than 7, we can choose from 1, 2, 3, 4, 5, 6. So there's 6 choices for event B. There's 5 choices for event A. So these are the outcomes for these events. So now, before we answer some of the probability questions, we should get familiar with the notation. If A denote the selected number is even, then A bar is the event that the selected number is not even. So therefore, P of A bar represent the probability of the selected number is not even, and if it's not even, then that's odd, right? Moving on, what does P of A or B represent? So this represents the probability of the selected number either even or less than 7 or both even and less than 7. Okay, so all those scenarios. What does P of A and B stand for? If P of A and B, then in this case we're looking at the probability of the selected number being even and less than 7. Right? Because A is the event of selected number is even, B the selected number is less than 7, so P of A and B refer to the probability of the selected number being even and less than 7 at the same time. So now we're ready to find the following probability. What is the probability of A, the event A? Well, there are 5 choices for A, so that's 5 out of 10 possible choice. So that's 1/2, right? The probability of event B occur, it means there are 6 different numbers can be less than 7, so that's 6 out of 10, so that's 3/5, right? And what is the probability of the event A and B occur at the same time? So how many numbers are there? How many possible numbers can be selected that is even and less than 7? There's 2, 4, and 6, so that's 3 out of 10, right? So now we are ready to find the probability of event A occur or B or A and B. So that means the probability of the selected number is either even or less than 7 or both even and less than 7. Okay, so to look at the first scenario, either even, so that's 6 even. Okay, and then less than 7, oh no, that's 5 even, sorry, that's 5 even, and there's 6 6 less than 7. So it's 11 total, but this means the probability of event A or B occurs, that's more than 100%. So we have to subtract something. Chances we double count. So if we count all this first 5 and we count again all this 6, we double count it. Why? Where is the double count at? So we double count it right here. If we count the first 5 possibility for the number selected even, we include 2, 4, 6, and the 2, 4, 6 also in the second event as well. 2, 4, 6. So we double count 3 numbers, so we have to subtract 3 out of 10. Now notice that the 3 possibility, 3 outcomes that we double counted is actually P of A and B in this case, right? And then this is our P of A, and then this is our P of B. So essentially that is our addition rule for probability. If 2 events are defined in sample space S, then the probability that A or B will occur is P of A plus P of B minus P of A and B, and we subtract if we double count. And if we double count, meaning this saying that we subtract if A and B share common outcomes. And there's a term for 2 events to share common outcomes, meaning they have they can occur simultaneously, and that's going to be the next page where we define those 2 events are mutually exclusive if both events have no outcomes in common, and cannot be occurred simultaneously or same time. Okay. So if 2 events that do share common outcomes or can occur at the same time, we say those 2 events are not mutually exclusive. Okay. All right. So moving on to example 2 here. Given a single 6-sided die is rolled, A be the event the number row is even, B be the event the number row is odd. So therefore P of A, the probability that the number row is even, 6-sided. That means 3 even and 3 odd, so that's 3 out of 6, which is 1/2. The probability of the number row is odds, that's also 1/2. The probability of the event of A and B occur, meaning if we roll a 6-sided die, what would be the chance, what would be the probability that the number row is even and odd? This is not possible, so this is impossible. We can't have the number landed on both even and odd because each side there's only one number. So in this case, the answer is 0. All right, the probability of A and B are 0. So now to find the probability of A or B occur, that's 1/2 for the number row being even, and then the other 1/2 for the number row is odd, and then those 2 can occur at the same time. So we're not subtracting anything. So in this case, it's 100% or 1. Okay. G, what can we say about the occurrence of event A and B? We say that the occurrence of event A and B cannot happen or occur at the same time. And the term for that is they are considered to be, they're called mutually exclusive event if 2 events cannot occur at the same time or don't share common outcomes in the next page here. Okay. Give 2 examples of mutually exclusive events. Okay, what would be the 2 examples that we think of that where 2 events cannot occur at the same time? All right, you can think of one. I'll come up with a couple, and then you can think of one as well. So here's some example. Right, let's see. Event A, a coin, toss a coin lands on heads, versus event B, a coin lands on tail, so I picked the easy ones there, right? Let's see here. Another good one is when you go through the intersections. This one I got from the student here. Let A and B, A be at the intersection, turning left at the intersections, and then B be the event, the car turning right at the intersection. Right, so if you think about this, if you're driving and you come up to an intersection, these two events here, there's no, I mean, you can just look at this, no cars, there's no, you know, car that would turn both left and right at the same time when they go through the intersection. So this can't be happening. So these are mutually exclusive. So you can come up with the last one here. Okay, I'm gonna go ahead and end on this first video here, and I'll make a couple more for this 2 lesson.